All right, now to the fun section. Okay, I was going to say the dreaded section, but I bet you all are looking forward to this one. Okay, so example 4. All right, why am I not even just on the net? You know what? there's nothing interesting that's going to be able to fit on that page. Graph the following on the same axes. All right, now there's 2 ways of doing these. All right, I want you to graph f of x is equal to the common log of x, and g of x is 10 to the x. So right now, I'm hoping by this point, after talking about logarithms for this much and doing this many homework problems, I hope you can recognize, oh, these are inverse functions of each other. Okay, the common log, that's log base 10, is the inverse function of 10 to the x. Okay, so we should have that symmetry that we mentioned at the beginning of the section. All right, if you've got a graph over here, let's go intent. Let's go 10 in all directions. Bigger hash marks for the 5. All right. Oh, excuse me. We do this. We can make a table. If you're ever curious, if you're ever uncertain, if you're ever lost on a graphing problem, make a table and just plug some stuff in. Especially here, we have the common log. You can plug things into your calculator, okay? Totally all right. But we're going to logic our way through this. 10 to the x, right? Remember, we have exponential form a b to the x. A is the starting value. We don't have an a right here. So the starting value for our exponential function is 1. The y-intercept, just like so. Okay? And then our growth rate is 10. Every time x increases by 1, boom, we're like way up here. Not off the video. You can't even see it anymore. Okay? And then to the left, every time we decrease, we get divided by 10. So we got this incredibly steep exponential function. And that's f of x. Okay? Now, g of x, sorry. And that's g of x, the exponential function. So inverse functions, right? You switch the x's and the y's. So if we have the point 0, 1 for g, that's going to be the point 1, 0 for f. Okay. We have the point 1, 10 for g. That's going to be the point 10, 1 for f. And similarly, if we have the point -1, 1/10, that's going to be the point 1/10, -1. And that's one way that you can approach these problems. So the logarithm goes really, really fast in the other direction. And then we have the asymptote of the y-axis. This is f of x, this is g of x, and we have that symmetry, right? Inverse functions should always have symmetry about that diagonal line. That's not the only way to graph these, but it's one way to graph them. We're going to show another way to graph them in probably example 5. Okay. So part B is a little sad. There's no symmetry in part B. F of x is equal to log base 4 of x. G of x is equal to the natural log. So in part A, we really just showed, okay, what do inverse functions look like? All right. In part B, we're going to compare, if I have different logarithms, what do they look like? All right. I'm going to use actually a different color for one of them. Okay. So we're graphing 2 different logarithms. Let's count to 5. All right, so let's make a table. F and f of x. X and f of x. While we're doing it, let's make g of x part of the table as well, right? F, remember, was log base 4 of x, and g was the natural log of x. Okay? So, what do we got here? We just plug in some values of x. Normally we start with 0, but you don't want to plug in 0. If you try to find the natural log of 0, your calculator will give you a very angry answer. Okay? So we're going to do things that make sense here. Anything bigger than 0 is going to make sense because the domain is when the inside is bigger than 0, when the inside is positive. Any positive number we want to include, we can. And remember that we have this vertical asymptote right here. Okay, so start 1. Log base 4 of 1. And remember back to the earlier video, any logarithm of 1 is going to equal 0. Log base 4 is 0. Natural log of 1 is equal to 0. So they actually both go through the point 1 comma 0. We got the black graph go through here. The red graph goes through here. Can't see the red through the black, but it's all good. And we can plug in some more numbers. You can plug in 2 and get an approximation, but log base 4 of 2 is not easy to find. Log base 4 of 4, though, is not too bad. Remember back to the previous video, previous section now. This is, right, 4 raised to what power is equal to 4? The answer is 1. We have the point 4, comma 1 on the graph. And then we also need to know what is the natural log of 4. We'll have to type that into the calculator. Okay. Just use your calculator to find the natural log of 4. And it's about 1.39. Usually I like 4 decimals, but for graphing, really graphing 1 decimal would be enough. So it's a bigger number. 1.39 is just a little bit bigger. And we can plug in some more numbers, but they're not really going to fit very effectively. So it's kind of hard to graph these on the same axes. But the important thing is that the red graph, g of x, just gets a little bit bigger, a little bit faster. It has the same asymptote. Okay. I'm not going to be super picky on this. The idea is that you can just give me a couple points that are good and get the general shape with the asymptote. All right. So we're going to finish with a bigger graphing problem. Example 5. Graph the following. I wish I wasn't getting such a glare from the sun. Anyway, thank you, snow. Graph the following. F of x is equal to negative 1/2 the natural log of x plus 1 minus 3. Okay, function transformations are happening everywhere here. This is getting moved left 1 unit. It's getting vertically compressed by 1/2. It's getting flipped upside down about the x-axis. That's what the negative does. And then after all of that, it's getting moved down 3. So it's going to be a logarithm, but there's so many things happening to it. It can be a little hard to see what's going on. So what we're going to do, let's start with talking about what we know, incorporating the stuff from earlier on in the section. Okay. For example, the domain. The domain of this is all the numbers where x plus 1 is positive. The domain is going to be all the numbers bigger than negative 1. So as we start plugging in values and looking at x's and y's, we're not going to plug in negative 1 or anything smaller than that, only things bigger than negative 1. And specifically, right, that tells us our asymptote is at negative 1. So one of the best ways to start graphing a logarithm is by graphing its asymptote. That's going to help a lot. And now we're just going to start plugging in numbers that are bigger than 1. 0, 1, 2, 3, 4. Okay? And you'll just plug them into your calculator. So when x is equal to 0, y is going to be negative 1/2 times the natural log of 0 plus 1 minus 3. Actually, this is one of the rare ones that we don't need a calculator for, but You can do it anyway to check your answer. You're going to get -3 because the natural log of 1 is 0. We have the point 0, -3 on this graph. You plug in x equals 1. You're going to get -1/2 times the natural log of 1 plus 1 is 2 minus 3. You plug that into your calculator. And this one is a little bit more interesting. -3.35. And it goes on. We don't need a ton of decimals here. -3.35, so a little smaller. When x is equal to 2, we get y is equal to -1/2 the natural log of 3 minus 3. You plug that into your calculator, you're going to get -3.55. So again, a little smaller. And in fact, we're really going to get this going on very similarly. Let's not plug in 3 and 4. Let's plug in 5, right? This is not changing very much. Let's move a little further. If you plug in 5, you get -1/2. Natural log of 5 plus 1 is 6. Minus 3, like so. And again, still not very big, -3.9. But at least we're almost at 4. So it's growing, but it's growing very slowly. That's that vertical compression in action. Okay. But notice that it is still growing down here. And then it's going to curve the other way and approach our x-axis. So it's flipped upside down from our normal logarithm. And you could plug in some fractional values right here, like -1/2, and get some values over here as well. All right, and it's going to look something like this. And for all of these graphing problems, absolutely recommend checking your answers. Okay, so let's go check our answers. Let's see if it looks like this. Okay, we got something over here. We have y, oh my word. Y is equal to -1/2 times the natural log of x plus 1 minus 3. And in our graph, we went from -5 to 5. And in the y's, we went from 5 to 5. Yep, there we go. It's exactly what our graph looked like. The y-intercept was at -3. We had that as well. The x-intercept, we didn't find that. But notice, we can get really, really close to x being 1. X will never actually be -1. All right, so that's our asymptote right there. You can even flip between them and look, whoa, how similar. Jason, you are amazing at accurately graphing things by hand. Wow. All right, so use this to check your answers. All right, and that's this video. Good luck on your homework. Email me any questions or Canvas or Slack, etc. Let me know, and good luck.